Hello, my name is Scott Cheatham and I'm with the Richmond Hospital Education Program, and today we're going to be doing a lesson on factoring. This is a topic that comes up first in Algebra 1, and so I'm going to gear this towards Algebra 1 students. However, it comes up for the rest of your high school career in both geometry, Algebra 2, and beyond, and so if factoring is something that's giving you a hard time, or if you could just use a refresher on it, then this would be a great lesson for you to listen to and work through with me. Throughout this, there are going to be times where I might ask you to pause the presentation and work out a couple problems. And so have some scratch paper around. That's going to be helpful for us. However, you won't really need a calculator for this, although it might be helpful for some of the things we might do. So feel free to kind of have that available to you. So as a warm-up, I'm going to give you 6 problems, 3 on this slide and 3 on another one, to expand. And so when we start talking about factoring and factoring trinomials, how we expand binomials and how it relates to trinomials is something that's really important for us to kind of feel comfortable with. This is going to go over and assume that you have some comfort with exponent rules and multiplying these binomials out. If you don't, you can kind of listen to as I talk through them, but these are some principles that we're not really going to get into too much in this lesson. We're just going to kind of assume that you have those. And so go ahead and pause the presentation now and see what would you get if I asked you to expand these 3 problems. So the first one here, I have our answer. When we're multiplying this, you might remember the term FOIL. FOIL just means first, outer, inner, last. And basically, we are multiplying each term in each parentheses by each term in another parentheses. So the first terms were the 2x squared and the 3x. The outer, were 2x squared and minus 4. The inner terms are the 5 and the 3x. And the last terms are the 5 and the minus 4. And so when we're multiplying these, the coefficients in front we multiply. If we are multiplying variables, remember we're going to add the exponents from those bases, assuming they're the same variable. So 2x squared times 3x, the 2 times 3 is 6. X squared times x, that x is x to the first, and so we add those exponents and get x to the third. Once you do multiply all of these out, you would ask yourself, are there any like terms that I need to combine? In this case, there are no like terms, meaning there's no variables with the same exponent that we can combine together. Now, 2x plus 3 to the third, I will say that a very common mistake for this is for people to cube 2x and to cube 3 and say that's it. And that's not the correct way of doing that. So let's look at another way how this could be written. So 2x plus 3, that plus is kind of like glue. It keeps that 2x plus 3 together. We can't just like cube the things separately. Now, I've written these out 3 times, so what you can do is just focus on the first 2, kind of cover up the third, and multiply that out, and then expand from there. So let me go ahead and show you what that would look like. So here we have 2x plus 3 times 2x plus 3. When you multiply that out, you get 4x squared plus 6x plus 6x plus 9. And then when you combine those like terms, you get 12x as the middle term. Now, when you're then going to multiply that times 2x plus 3, we're going to multiply each term in the first trinomial now times each term in the second binomial. Sometimes people make a box diagram with this to make sure that they're multiplying everything in the first trinomial times everything in the second. Here I've just written it out. You want to make sure you combine your like terms, so combine those x squared terms and the x terms, and here's your final answer. Now for this third one here, we don't have a number as the exponent, we have the letter n. And so the same process of how you would combine things is if this was a 2, a 3, a 5, or an n, we're going to follow those same exponent rules. So let's look at what that would look like. So here, when you have 2 times 3, we get 6. X to the n times x to the n, well, we would add those exponents. N plus n is 2n, so our term there would be 6x to the 2n. Then we have minus 5x to the n once we combine those middle like terms, and then minus 4 is our last term. All right, here are 3 more problems, kind of following a similar one. If you need to make a box, I would suggest doing that for these if that helps you visualize which ones you're gonna multiply. So go ahead and expand these out. So here, we multiply again 3x squared times 2x and minus 3. You multiply the negative 4x times 2x and minus 3, and then the 1 times 2x and minus 3. And then combine our like terms. For this one, and you can think of this because we're going to have 9 terms to start, and then we need to combine them. And the tricky part with this is that now you've got exponents of x to the third, x squared, and x. They're kind of interchanged. And so one good strategy is to kind of slash through with your pencil when you've used a certain term to combine it. You want to kind of be careful here that when you do that, you haven't forgotten a term or used a term twice. Now this last one, admittedly, is a little bit complicated, but I wanted to show it to you just to reinforce that these exponent rules and things we're doing are going to hold true no matter how it looks. We're just going to follow the same basic exponent rules that you've already learned. So here, and we're adding those exponents since we're multiplying them. There's your answer. Now, for factoring, it's basically the opposite of what we just expanded. Factoring would be taking those expanded forms and rewriting them as binomials or as factored out trinomials. And factoring gets used quite a bit whenever you're dealing with quadratic functions, with x squareds. It's a way of rewriting things, and sometimes it's a way of solving for problems, a way of graphing things easier. Factoring gets used quite a bit throughout the rest of your high school math experience. And so we want to feel comfortable with how we can rewrite things and how we can manipulate them around. Now, when I like to first expose people to factoring, if you've ever used algebraics, they're a great tool in order to kind of visualize or great manipulative for you to touch and move things around to kind of see, well, why can I rewrite this as this? We're going to go over kind of just the numerical part a little bit later, but I wanted to show you kind of from an algebraic standpoint how this can be physically represented. Now, ideally, you would have some of these you can play around with, but since you're watching this lesson, we're not able to do that. There are a number of modules online. If you just search for algebraics, how you can kind of play around with these in order to do them. But so these algebraics, if you've ever touched them, you'll notice that you have a square for x squared, and then you have a rectangle for x, and then a smaller square is the number 1. And what you notice, and it's evident here, if you think of the length, so the the measurement of one of the sides is x, and then for the rectangles, one of the top sides is 1 times x, that's 1x. And you notice that the dimension, the width on the x and the width on the 1 are the same. For the x squareds, you've got 2 sides there that are whatever our measure of x is. And so really this is a way where we don't have to assign a number for x. but we can go ahead and say that it's a certain value that we can represent here. Now, in order to factor this, what we're going to do is we're going to try and make a rectangle. So if you want to kind of sketch that out, you can try and do that, but I'll show you kind of this first one, how it would look. So here we have the x squared, and we had 5 x's, so I kind of made them into a rectangle kind of on the side, and what worked out nicely is my 1's I could fill in, and I've got a full rectangle. I don't have any kind of odd things sticking out or anything not included. And so if we just look at the dimensions for that, if we look at the top, we've got that x squared, one of the sides is just x, and then we've got 1, 1, 1. And if we look at the left side, we've got one of the sides is x, and then we have plus 1, plus 1 for those x's. So if you actually were to take the dimensions of the sides, the top is x plus 3, and the bottom is x plus 2. And if you multiply those two things together, x plus 3 and x plus 2, you get what we originally had, or x squared plus 5x plus 6. So this is a way of kind of representing it in a physical form and kind of seeing how these factoring ideas are related. Now, the other thing I will say is if you did your your rectangle kind of oriented a little differently, or even if you just wrote the x plus 2 first, that's fine. In factoring, we're going to have oftentimes 2 binomials, and it does not matter the order you write them as long as your signs are correct. Here they're both positive, so that's fine. If we have a negative, we just want to make sure the negative number is with the correct number it's supposed to be with. Now here we have negative 3x. And so for negative 3x, we still can make a rectangle, and that's fine. That's just going to change kind of what some of the numbers that we have are going to be. So here you can see this rectangle and how I placed it. Now you'll notice that those 1's stayed positive, and if you think of this as multiplying, that's because we had a negative 1 times negative 1 is going to end up making those 1's positive. Theoretically, and we'll see in a second, you can have some positive x's and negative x's that might make that a negative 1, but in this case we're going to have this be positive 1. So let's look at the dimensions of our sides. We have x minus 2 and x minus 1, and if you multiply them together, that's your full rectangle. Now notice here, if you expanded, like we were doing for that warm-up, if you expanded x minus 2 and x minus 1, combine your like terms, you would have what we originally were trying to factor. So that's kind of how these ideas are related. Now, for these, we have 2x squared plus 1x, and then minus 6. Now, the tricky part with this is if you're going to try and make a rectangle, it really doesn't work with the way these are set up. And so that's not to say that you can't factor it, but what we're going to do is we're going to have to kind of get a little creative with how we make our rectangle. And so sometimes the x tiles and the 1 tiles are not going to be enough for us to be able to make a rectangle as the problem is originally stated. Now, what we need to do is we can add certain things in order to finish out that rectangle, but if we do add something, we need to offset it. I mean, if we're going to add some x's to fill out our rectangle, we need to add negative x's to offset it. We don't want to change our trinomial, change what it equals. We're just kind of think of it as adding plus x and minus x, or adding plus 1 and minus 1. We haven't changed anything. We've got a little bit more terms to play around with how we're going to make our rectangle. So our rectangle here, you could have played around with this if we had the physical algebra blocks. And see, in order to make one, you really kind of have to add a total of 3 x's. And so in order to add 3 x's, I need to also then include 3 negative x's. And that's what those x blocks are there with the minus sign on them. And what this does is it creates, okay, one of my sides has x plus 2, and one of my sides has x minus 3. And you'll notice that the 1 blocks, because I've got a plus 1 and minus 1 as my links there, because I'm multiplying a plus 1 and minus 1, those 1s are going to be negative. And as far as the dimensions go and what would be the factored form, it's going to be 2x minus 3 and x plus 2. Now, algebra blocks are not always going to be the most practical way. Now, some people are able to do these in their head. Some people need to make a little chart where they write out the factors and see what it would look like, and that's fine too. A little t-table where on the left you write out the factors of, for the first one, 8, and then on the right you write out what would it add to be 6. But so I think you can ask yourself this question and try and think through it in your head. For number 1, what two numbers multiply to get 8 that add to get 6? Now, again, while we were talking about the signs, we know that because it's plus 8, those signs have to be the same. So they're going to be either both positive or both negative. But because that 6x is positive, we know that they're actually both going to be positive. And so I like starting with focusing on those signs because it really is going to help you. So you, rather than saying what two numbers multiply to get 8 that add to get 6, okay, I can think of it, what two positive numbers multiply to get 8 that also add to get 6. So go ahead and give these a try. See if you can come up with numbers that would give us these values and how you could rewrite them. So for this first one here, you've got what two numbers multiply to get 8 that add to get 6. And I'm written that out as x plus 4 and x plus 2. If you wrote x plus 2 and x plus 4, then that is completely okay. That's the same answer. But here we're going to, if you expanded out that second term, if you expanded out that second line, you'd have x squared plus 2x plus 4x plus 8. And again, those middle two terms would combine. That's where we get the 6x from. So really, what we're doing here is we're just rewriting a trinomial as two binomials. When we were expanding, we rewrote two binomials as one trinomial. And being able to rewrite this is going to allow us to do some solving and do some graphing. It's going to be really helpful for us as we move forward. Now for number 2 here, our 4 is positive. So I know that in those two binomials, it's going to have the same signs. And because that minus 5x is negative, the sign is actually going to be minus. So I can think of it, okay, what two negative numbers multiply to get 4, that when you combine them, those negative numbers give us negative 5. In this case, we have negative 4 and negative 1. And the more you practice this and the more you try and do it to where you're just kind of thinking, okay, what two numbers multiply to get this that add to get this, the numbers are going to come up and be much easier for you. All right, now for this one, the one thing I'll point out there is we do need to rewrite it in that standard form there. We don't, here the 10 was in the middle. And sometimes people might say, okay, what two numbers multiply to get 7 that add to get 10? That kind of phrasing only works when it's written in the correct form. So what two numbers multiply to get C that add to get B? What two numbers multiply to get 10 that add to get 7? 10 is positive, and so my numbers are going to be the same. Sign-wise, it's positive 7, so they're both going to be positive, and 5 and 2 is our answer. Now the last one here is going to be, again, I had to rewrite it. Two numbers that multiply to get positive 33 to add to get negative 14. They are the same sign, but because it's negative 14, they're both going to be negative. And those two numbers are negative 11 and negative 3. Now again, thinking to the signs, now sometimes we're going to have the second sign as negative. Now when the second sign is negative, that means that the factors in the binomials are going to have different signs. Now, depending on the way the trinomial is written, you might see in the trinomial minus minus or plus minus. But again, the binomials is what's going to have the different signs. And the way you decide that is, again, by saying, okay, what two numbers multiply to get the third? If it's minus, we're going to have ones plus and ones minus, that add to get the second. Now, that second number, that sign there is generally going to go with the larger of the two numbers from an absolute value standpoint. So let's see what I mean by that. So here, for number 5, x squared minus 5x minus 24. What two numbers multiply to get negative 24? Then when you combine them, you get negative 5. Now, when I think of factors of 24, or negative 24, you've got negative 12 and 2, negative 8 and 3, negative 6 and 4, and those flipped around. Because that first sign with the negative 5 is negative, the larger number, whether that's negative 12, negative 8, negative 6, that's going to be the one that's going to carry the sign and be negative. So when you're combining them, it takes a little practice to get comfortable with that, but that is going to be something where that first sign is going to kind of help you point out which number is going to get which sign. You could have the right two numbers and have the signs flipped around, in which case it would be incorrect, so you have to be careful there. Go ahead and pause here and see if you can kind of solve for these next 4. For this first one here, what two numbers multiply to get negative 24 that add to get negative 5? That is negative 8 and 3. And notice that 8 being the larger absolute value number, that's the one that gets the sign, the negative. It was with the 5x, and you have 3. This next one, there are not a set of numbers that when you multiply them to get negative 24 add to get 12. And the reason is, you might say, oh, well, what about 6 and 4? No, that doesn't work. 8 and 3 doesn't work. 12 and 2. There are not a set of numbers that work here. So this is going to be what we call not factorable. That's okay. That happens frequently where you have an answer that's not factorable, and you just write not factorable as your answer. Now for this one, I did need to rewrite it in the proper form. And what two numbers multiply to get negative 30 that add to get negative 7? Negative 30, they're going to be different signs. Negative 7, the larger number is going to be the negative 1. So we get negative 10 and 3. For this one, again, it's not in the right order, so we do need to rewrite it. What two numbers multiply to get negative 45 that add to get 12? Answer being positive 15 and negative 3. Now, there are a number of special cases in factoring, and today I'm just going to show you one of the most popular ones. This is called the difference of two squares, and I'll explain what those A's and B's mean in just a minute. But what we're going to have here is you have to have a difference, meaning you have to have a minus sign, and it has to be two perfect squares. So x squared is x times x, 4 is 4 times 4. And let me show you a different way how you can think of that being written. So rather than thinking of it as just x squared minus 4, what if you think about it as x squared plus 0x minus 4? What are two numbers that multiply to get negative 4 that add to get 0? Well, if something's going to add to get 0, it's got to cancel out and basically one be the positive and one be the negative version. So two numbers that multiply to get negative 4, well, 4 is a perfect square, so 2 and 2. In this case, because it's negative 4, we're going to have positive 2 and negative 2. That would multiply to give us negative 4, and when you combine them, you get 0. Now, rather than writing that out as x squared plus 0x minus 4, we're just going to leave it as x squared minus 4, and you can use this difference of two squares formula, where basically you're taking the square root of each term, x squared and 4, and one's going to be positive, one's going to be negative in the binomial, and that's your factored answer. If I wanted to check it, multiply this out, the middle terms cancel, I have my original problem. So this is a very nice way of working through it. So go ahead and write these out. What would you get if you were factoring them completely for these using this difference of two squares formula? So again, the things we have to have a minus and we have to have perfect squares. For this first one here, we've got x plus 3 and x minus 3. Now, if you wrote x minus 3 and x plus 3, that's technically correct, and that's fine. That wouldn't make a difference there. For 4x squared minus 25, now we do have that 2x there, and so that's fine to take the square root of that. If it was 5x squared, it wouldn't work because it wouldn't be considered a perfect square. But this case, this one does. Now this next one here, x squared and 49 are both perfect squares. However, it's not factorable because it's not the difference of those two. It's a plus 49. So we just write not factorable. If you wrote this out, there's not two numbers to multiply to get positive 49 to add to get 0x. It does not work. It's not factorable. X to the fourth is considered a perfect square. We can take the square root. It's x squared times x squared and still have the plus y and the minus y. Now for this one here, we've got x squared plus 9 and x squared minus 9. Those are the square roots of those. Those are perfect squares. The one thing I want to point out here, though, and this is something that's going to come up quite a bit in factoring, is your instructions are to factor completely. There might be some times where you can actually factor a second time. And so you do have to be mindful of that. So not for the x squared plus 9 because it's not a difference problem, but for x squared minus 9, we actually can factor it again. And when you do that, you get another difference of squares, x plus 3 and x minus 3. That only worked because we started off with x to the fourth and then we had x squared in the next one. If you just had x minus 9, it would have to stay as it is. But this is the way of factoring it completely. I hope this kind of introduction has been helpful. There are more special cases, and then oftentimes when we get into trinomials where that leading coefficient is greater than 1, there's some more processes and steps and things to think about. But I hope that this has been helpful for you. For some extended practice on IXL, if you're still with the Richmond Hospital Education Program, we have a subscription to that. Many school systems do as well, to where you can do some extended practice on factoring those quadratic where the leading coefficient is just 1. Thank you very much for listening to this, and I hope it's been helpful, and I wish you well in the rest of your school year.